Lowe's Hardware is a major hardware store known across the world, originally founded in North Carolina. The Lowe's Quality Assurance team at the Mooresville headquarters tasked the senior design team to design and build a pressure testing device to test current and future products. While talking to the Lowe's Quality Assurance team at the kickoff meeting, the team came up with a list of parameters that device needed to be able to perform. The device must be able to hold between 200 and 2,000 psi and perform 2 tests, one test to pressurize till failure and the other to hold for a certain amount of time up to 2 hours. The device must also have a simple and easy-to-use display and be corrosion resistant to accommodate for the fact that the device may not be used all the time. Because of the high pressure required, the team decided to use water to minimize the safety risk, as well as incorporating other safety features such as a locking mechanism on the lid and emergency stops. The device needed to be able to accommodate up to a 200-foot garden hose and products that only had single-side inlets. Because of this, the team decided on a 2-foot square tank that would also act as the water reservoir. The tested products will be submerged in the water to disperse any burst that may occur. To achieve our 2,000 psi max limit, the team decided to use a North Star pressure washer and a safety relief valve to create a continuous flow system. An air-loaded dome pressure regulator would bleed off of the main flow line to transmit the correct pressure to our part. To prevent locking of our pressure washer and pressure regulator, both tests, single outlet and double outlet, will have bleed lines back into the tank. A normally open solenoid valve between the pressure washer and safety relief valve will allow for pressure release if the product is to lose power or need to depressurize. After a lot of research, the team decided on a Swaglot RA4 series regulator to control the pressure in the part. This pressure regulator was chosen for its ability to change pressures quickly and efficiently without running the risk of fatiguing a spring. The Lowe's test team went to visit the quality assurance team at the Lowe's Mooresville headquarters. While there, the team decided to use 80/20 for the stand of the device to match what the Lowe's team already used, as well as using a Click PLC with a Seymour EA9 series touchscreen. The team then took to Creo to design a stand to accommodate the hard plumbing, tank, and pressure washer, as well as the electrical box mounted for easy access. The Lowe's Quality Assurance team offered to have our stand design built to allow the team more time to work on the hard plumbing and electrical assemblies. The electrical sub-panel was designed using Autodesk and provided an easy naming system to identify parts. By the end of fall 2019, the team was ready to order all the parts and begin assembly in the spring. At the beginning of the spring semester 2020, the Lowe's Quality Assurance team visited UNC Charlotte to deliver the stand, pressure washer, and raw components for the tank. The student welder was contacted and work on the tank began. The tank took over 20 hours of welding to accommodate all the sides, angle irons, and baffles at the bottom of the tank. The bottom of the tank was also bent in a corner to allow for an angle for easy draining of the water. The electrical subpanel was assembled and all wires were run neatly to assure ease of use. The default screen for the HDMI display is the burst pressure testing screen. The first thing to note is that the current pressure, which comes directly from the pressure transmitter, is displayed very largely. This is done so any bystander can easily see the active pressure even from afar. Another built-in safety feature is that when the system is pressurized, the border of the screen turns red to act as an indicator light for anyone who is near. On the right side of the screen, there are screen navigation buttons to switch between the 4 different screens. The blue icon, when pushed, shows a pop-up screen that tells operators certain information to save time from referring to the manual. For the burst pressure test, the user only has 2 inputs. Selecting a single inlet device like a valve or a double inlet device like a hose. Also selecting the speed at which the tests are performed, with slow being the default. Once the user wants to start the test, they must first initiate the system to get rid of the air. After waiting a period, they can start the test. The next screen is for the time set pressure testing, which only takes 2 new user inputs from the previous screen. The user can select a time for which the test takes, from 0 to 120 minutes, and also set the pressure at which the product undergoes the test, which can be from 120 psi to 2000 psi. The data screen can be accessed at any point to see the pressure graphed over time in the system. The process overview screen allows operators to manually control the system instrumentation and the equipment such as the pump and solenoid valves, as well as change the set point for the dome loaded regulator. This screen allows the operators to drain the system through this button, which allows both solenoids to open and depressurize the apparatus. The week the team was planning to test, the labs closed due to current circumstances. The Lowe's team met with the Minter and quality assurance team to discuss what to do next. It was decided that the Lowe's test team would provide written instruction on how to finish assembling the device, as well as how to test the device to make sure everything is running correctly. The code will still be completed to the best of the team's abilities under the current circumstances. The tank is fully completed and equipped with quick connects for easy product testing. The HMI screen will be mounted on the gray box, as well as mounting the emergency stop. All the hard piping is assembled and mounted, only lacking a few hydraulic hoses to be connected. The tank's drain and pressure washer feed only lacks being connected with a hose. Wiring between the electrical box and the pressure transmitter and solenoid valves still needs to be completed. All of the components to do this have already been purchased, and holes prepared in the electrical box. The next step for this device is for the Lowe's quality assurance team to collect the device and complete it using the Lowe's test team manual. Once completed, the Lowe's quality assurance team will be able to pressure test products quickly and easily. This semester may not have gone as planned, but it has given us the opportunity to tackle tough circumstances and make the best of what we have.